Today I am going to talk about the topic capsule production. These are the contents that I will include in this slide. Introduction, capsule production process, improved capsule filling and manufacturing machines, layout, evaluation test, problems encountered, disperse systems, production process, application of mixers, classification of disperse equipments, problems encountered. Introduction of capsule. Capsules are solid dosage form in which one or more medicinal and inert ingredients are enclosed in a small shell or container usually made up of gelatin. It is of two types, hard gelatin capsule and soft gelatin capsule, because it is made up of two parts that resemble tiny cylinders that are closed at one end, the longer component known as the body and the shorter portion known as the cap, which fits over its open end. The hard capsule is also known as two pieces. One piece is another name for soft gelatin capsule. Some of the advantages and disadvantages of capsules are: advantages: odor and taste masking possibility, easy to handle and carry, easily swallowed, economical, attractive in appearance, therapeutically inert. Disadvantages: hygroscopic drugs cannot be used, cause irritation in stomach, they are easily tampered, more expensive than tablet. This is the production process of gelatin. In this we can do by two methods, that is alkaline process and acid process. We'll take split, bones, pig skins. In split, washing, grinding, liming process, washing, neutralizing, stage extraction. In bones, grinding, defatting, washing, macerating, washing, ocene. In pig skin, washing, grinding, hydrolysis, washing, stage extraction to form the gelatin solution. Hard gelatin capsules. Hard gelatin capsules consist of two pieces in the form of cylinder closed at one end. Shorter one is called cap and the longer one is called body, which fits over the shorter one. Hard gelatin capsules are also known as dry filled capsules or two-piece capsules. The drug substance placed in body and caps are sliced over it, hence enclosing the drug substance. Manufacturing of hard gelatin capsules involves following steps: dipping, spinning, drying, stripping, trimming and joining, polishing. Pairs of stainless steel pins are dipped into the dipping solution to simultaneously form the caps and bodies. Dipping solution is maintained at a temperature of about 50 degrees Celsius in a heated jacketed dipping pan. This is for dipping. In spinning, pins are rotated to distribute the gelatin over the pins uniformly and to avoid the formation of a bead at the capsule ends. Drying. Gelatin is dried by a blast of cool air to form a hard shell. Pins are moved through a series of air drying pins to remove water. Stripping. A series of bronze rows strip the cap and body portion of the capsule from the pins. Trimming and joining. The stripped cap and body portion are trimmed to the required length by stationary knives. After trimming to the right length, the cap and body portion are joined and ejected from the machines. Polishing. Pan polishing is usually done by Acilla Cota pan to dust and polish. Dusting. Capsules are rubbed with cloth. Brushing. Capsules are fed under soft rotating brush. This is the diagram of manufacturing of hard gelatin capsules. Filling of hard gelatin capsules involves hand-operated methods and semi-automatic capsule devices, punch method or manual filling, automatic filling machine, example, Osaka capsule filling machine or Macofar capsule filling machine. Hand-operated method. It consists of a bed having 200 to 300 holes, a loading tray with the same number of holes, a powder tray, a pin plate having rubber top, a lever, a cam handle. In this, how we proceed: the empty capsules are filled in the loading tray and it is placed over the bed. Cam handle is operated to separate the capsule caps from their bodies. The powder tray is placed in a proper position and filled with an accurate quantity of powder with scraper. Excess of powder is collected on plate of powder tray. The pin plate is lowered and then the filled powder is pressed. After pressing, the pin plate is raised and remaining powder is filled into the bodies of the capsule. Powder tray is removed after its complete filling. The cap holding tray is again placed in position. The plate with the rubber top is lowered and the lever is operated to lock the caps and bodies. The loading tray is then removed and filled capsules are collected. In semi-automatic machine, it requires an operator to be in attendance at all time, where once the workforces of the capsule filling industry. To date, they are more likely to be employed when smaller batch sizes are required, such as production of early phase clinical supplies. Quoted production capacities for powder filling range from 6,000 to 8,000 capsules per hour up to as high as 15,000 capsules per hour, depending on the capsule size. In fully automatic machine, most modern automatic filling machine employ pistons or tamping pins that lightly compress the powder into plugs and eject the plugs into the empty capsule bodies. The compression force are low, often in the range of 50 to 150 Newton, up to about 100-fold less than that employed in typical tablet compression. There are two main types of these fillers, dosator machines and dosing disc machines. These are the diagram of dosing disc machine and dosator machines. Locking and sealing of capsules. Banding. Placing gelatin color band at meeting point of caps and the bodies. Moistening. Moistening the inner surface of caps with lukewarm gelatin solution. Spot welding. Spot welding the joints which leaves a ring-like appearance at the point of sealing. Thermal welding. Applying wetting solution at the meeting points which cause lowering of melting point and applied area. Finally, they are sealed at temperature of 40 to 45 degrees Celsius. By using cone snap capsules, grooves help to lock the caps with the bodies. Soft gelatin capsules. These are formed in a single piece and are more suitable for oils, for example, fish oils or drugs that need to be dissolved in oils or other liquids to aid the drug to be absorbed in the stomach. In soft capsules, the drug is combined with an appropriate solvent in the center of capsule and the capsule shell melts within minutes in the stomach. Unpleasant drug taste and odors are masked by the tasteless gelatin shell. Soft gel's ability to enhance bioavailability not only makes them the preferred dosage form for new chemical entities with poor oral bioavailability, they can also be used for reformulation of existing drug with the purpose of life cycle extension. Some of the manufacturing equipments for soft gelatin capsule involve plate process, rotary die process, reciprocating die process, and ecogel process. Plate process. In this, place the gelatin sheet over a die plate containing numerous die pockets. Application of vacuum to draw the sheet into the die pockets. Fill the pockets with liquid or paste. Place another gelatin sheet over the filled pockets. Sandwich under a die press where the capsules are formed and cut out. In rotary die process, the soft gelatin capsules are prepared and then filled immediately with liquid medicament. It is of two types. It is having two hoppers and two rotating dies. Liquid mixture is placed in one hopper and the liquid medicament in other hopper. The two rotating dies rotate in opposite direction. When the fluid gelatin mixture enters the machine from the hopper, it produces two continuous ribbons. These half shell of the capsule is formed. At this stage, the measurement quantity of the medicament is filled into it with the stroke of a pump. With the subsequent movement of the dies, the other half capsule is formed. The two halves of the capsules are sealed together by the heat and pressure of the rotating dies. As the die rolls rotate, the convergence of the matching die pocket seals and cuts out the filled capsules. Reciprocating die process. It is similar to rotary die process in that ribbons of gelatin are formed and used to encapsulate the fill, but it differs in the actual encapsulating process. A set of vertical dies continually open and close to form rows of pockets in the gelatin ribbons. These pockets are filled with the medication and are sealed, shaped, and cut out of the film. Ecogel process. It is another rotary process involving a measuring roll, a die roll, and a sealing roll. As the measuring roll and die roll rotates, the measured dose are transferred to the gelatin linked pocket of the die roll. The continued rotation of filled die coverages within the rotating sealing roll where a second gelatin sheet is applied to form the other half of the capsule. Pressure developed between the die roll and seals and cuts out the capsules. Quality control of capsules involve whether capsules are produced on small scale or large scale, all of them required to be passed through certain tests, that is quality control test. So for some of the quality control tests for capsules are physical test, involves disintegration test, weight variation test, chemical test, it involves dissolution test, assay, content uniformity, stability testing, moisture permeation test. So some of the problems encountered in filling capsules are: first, deliquescent or hygroscopic powder. A gelatin capsule contains water which is extracted or taken up by a hygroscopic drug and renders the capsule very brittle, which leads to cracking of the capsule. So we add adsorbents like magnesium carbonate, heavy magnesium oxide or light magnesium oxide to overcome this difficulty. Eutectic mixtures. Certain substances when mixed together tend to liquefy and form a pasty mass due to formation of mixture which has a lower melting point than room temperature. Adsorbents used are magnesium oxide and kaolin. Addition of inert powders. When quantity of drug to be filled in capsule is very small and it is not possible to fill this much small amount in capsule, then inert substance or as a diluent is added so as to increase the bulk of powder. Use of two capsules. Some of the manufacturers separate the incompatible ingredient of the formulation by placing one of the ingredients in smaller capsule and then placing this smaller capsule in a larger capsule containing the other ingredients of the formulation. Filling of granular powder. Most granular powder are difficult to fill in the capsule by punch method because they are not compressible and flow out of the capsule. To overcome this difficulty, non-adhesive powder should be moistened with alcohol and the granular powder should be reduced to powder before filling into the capsules. Disperse system. Dispersion system is defined as heterogeneous two-phase system in which internal phase is distributed or dispersed over the continuous phase or vehicle. The internal and external phase may be solid, liquid or gas. Examples: suspension, emulsion and aerosols. Coarse dispersion is heterogeneous in which dispersed phase particles are larger than 1000 nanometer. Colloidal dispersion are systems consisting of discrete particles in size range of 1 nanometer to 1 mm. Molecular dispersion is mixture of two or more substances where one substance is finally dispersed within another at molecular level. Production process. Dispersed system involve several production processes to achieve desired results such as mixing, milling, dispersing, fine solid dispersion. Mixing is the process of combining different material or component to create a homogeneous mixture. It is essential for achieving uniformity and consistency in the final product. Milling. Milling is the process of reducing the particle size of a solid material, commonly used to create powder or fine particles which are easier to disperse and mix. Dispersing. The process of breaking down agglomerates or cluster of particles to achieve a uniform distribution, crucial for achieving stability and optimal performance in final product. Fine solid dispersion is the process of dispersing solid particles in liquid medium. It is commonly used in industries such as paints, coatings and inks. These production processes play a vital role in manufacturing of dispersed system, ensuring the quality and performance of the final product. Application of mixers. Blending, emulsification and dispersion are some of the application of mixers. Mixers used to combine different components to create a homogeneous mixture. This is commonly used in industries such as food and beverage industry, pharmaceutical and chemicals industry. Emulsification mixers are used to create stable emulsion by combining immiscible liquids such as oil and water. It is important in industries such as cosmetics, food processing and pharmaceuticals. Dispersion. Mixers are used to break down solid particles and disperse them evenly in a liquid medium. This is commonly used in industries such as paints and coatings, ink manufacturing and chemical processing. Classification of dispersion equipments involve mixers, high-speed dispersers, rotor-stator mixers, combination mixer, inline mixers, non-mechanical disperse processing, fine suspension and size reduction equipments. These are some of their subtypes. Mixers. Propeller mixer. The marine propeller mixer is a frequently employed mixing tool. These devices have three blades with a rounded pitched shape that primarily generates axial flow. In small quantities with low to medium viscosity, they offer good flow and mixing capabilities. Propeller mixer can be mounted via the process vessel side wall or on the vertical center line. They may run between 300 to 400 rpm. They are typically employed in applications involving liquid-liquid mixing in certain readily produced suspension. Turbine mixtures. The axially as well as circular flow turbines are the most adaptable mixers in the whole range of mixing apparatus. Turbine mixers are appropriate for emulsification process and can handle large batches up to 500 million gallons. Anchor mixers. Both its speed and its capabilities are modest. The only purpose of slow anchor agitator is to spin a batch contents radially without causing any noticeable shear. They are made to be able to tolerate a maximum viscosity over which they may actually shatter or merge. Agitator with scraped surface. Scraped surface agitator are movable or flexible blades that are fixed to the anchor with the intention of scraping the side walls. In emulsification apparatus, when heat transfers are required, they are unquestionably necessary. Agitators with counter rotation. Its anchoring agitator as well as counter rotating crossbar arrangement offer superior mixing. Materials having viscosities between 5,000 to 25,000 CPS, that is centipoise, respond well to these. Certain mixing possibilities are enhanced by installation of a fixed baffle. Dispersers with high speed, saw blade dispersers. This machine is made up of an impeller having an edge that is attached to a variable speed shaft. The point speed is around 4,000 feet per minute. The impeller diameter ought to be one-third that of the vessel. One impeller diameter above the vessel bottom is where an impeller should be placed. Particles can be dispersed when viscosity is between 10,000 to 20,000 centipoise. Some of the applications involved are paints, dye products, carbon dispersions, and pigment dispersions. Limitations: better to employ air inclusion for suspension rather than emulsion due to another issue with it. Rotor stator mixers. The impeller of this mixing machine is mounted with strict tolerances to a fixed housing which impedes and baffles the flow of liquid induced by impeller spinning. The impeller's mechanical action presses and separates particles that are trapped between the rotor and stator. Some of the categories are radial passage using a stator that rotates, rotor stator mixers with axial flow. Combination mixers. Improved management of pressure and temperature removes line losses brought up by pumping between tanks, conserves floor area, streamlines the procedure, and reduces labor expenses. Some of the types of combination mixer include rotor and stator plus anchor, disperser and anchor combined, coaxial rotor stator counter rotating, rotor and stator plus anchor. It is a rotor-stator mixer combined with a basic anchor agitator. It offers substantial shear speeds for emulsification and dispersion. If it's necessary to remove powder from top, it's advantageous. Limitation: it is challenging to build the anchor in a way that permits the high shear mixer to be positioned at the bottom. Coaxial rotor-stator counter-rotating. Known as triple action mixer, this design combines a high-speed rotor-stator blender with a typical anchor-style scrapped interface agitator and the exceptionally powerful combining characteristics of counter-rotating axial circulation crossbars. It can function at 50,000 centipoise of viscosity. Since it is required while making creams and ointments, they always remain jacketed during heating and chilling. Benefits: able to handle a broad spectrum of viscosities including water thin to up to 1 million centipoise, emulsify and disperse with great efficiency, gives the quickest time for mixing. Some of the disadvantages are difficult to clean because of intricate design. Line mixers. Disperser, emulsifier, rotor stator blender. It is possible to construct these mixers that function as submerged pumps so that the product may be pushed through them by enclosing rotor stator inside the pump casing. The product in the rotor stator blending pump is made up of particles and droplets that are exposed to a range of extremely high stress rates. Low quality rotor stator gaps in its design encourage elevated stress rates and significant shear loads each pass through. Colloidal mill. It is employed for emulsifying liquid system and scatter particles into liquids. These are typically employed as emulsion or suspension polishing machines because they generate tiny particulate or droplet sized products that increase a product's stability. The rotor stator mixer run at a speed of 3600 rpm depending on the viscosity. The rotor diameter of 10 to 30 cm can offer flow rates between 4000 to 6000 liter per hour. Benefits: greater shear rates than in stator rotor machines. Particle size attainable with constant gap. Rotor stator blenders are larger than those of the emulsions and suspensions produced by the colloidal mills. Limitations: lower flow rates compared to stator rotor machines, not applied to abrasive fluids. Some of the problems encountered with disperse system are clogging, poor dispersion, equipment maintenance. Clogging is a common problem in disperse system. It occurs when particles or materials become trapped in the equipment, obstructing the flow and causing disruptions in the production process. Poor dispersion is another issue that can arise in disperse system. It occurs when the particles or materials are not evenly distributed throughout the mixture, leading to inconsistencies in the final product. Equipment maintenance is crucial in disperse system to ensure optimal performance and prevent breakdowns. Regular cleaning, lubrication, and inspection of equipment are necessary to identify and address any potential issues before they escalate. These are some of the references. Thank you.